Good afternoon, my YouTube viewers. In this video, we're going to talk about Spearman's rank coefficient, which is also a measure of association. It's similar to the Pearson's rank coefficient. So the Spearman's rank coefficient measures the monotonic relationship between two variables. It's often used for ordinal or non-normally distributed data. So it has a range of -1 to +1. So if it's -1, it's perfectly negatively correlated. And if it's +1, it's perfectly positively correlated. And if it's 0, there's no correlation. So what we're going to do is we're going to write a program in Python to prove the Spearman's rank coefficient. And when we write that program in Python, what we're going to have to do is we're going to have to import a library that we're going to need to use it to execute the program. So from scipy.stats, we're going to import Spearman R. So scipy is Python's scientific library, and stats is the statistical module within scipy. And Spearman R is the model that we're going to be using. So after we have imported the library, what we want to do is we want to create some data. So your X variable, which is your independent variable, is a list of numbers 10, 20, 30, 40, 50. And your Y variable, which is your dependent variable, is also a list of numbers 5, 10, 18, 19, 16. So we're going to calculate the Spearman's rank correlation coefficient and p-value. So RHO, that's like a test statistic, p-value equals Spearman R bracket x, y. Now your p-value is a probability. So we're going to display our results of x, y, the Spearman's rank coalition, which is RHO, and the p-value. So you've got your X, which is a list of numbers from 10, 20, 30, 40, 50. You've got your Y, which is a list of numbers, which is 5, 11, 18, 19, 16. You've got your Spearman's rank correlation coefficient, which is 0.7. So that means it has a positive correlation. You've got your p-value, which is 0.188. So the null hypothesis is the values are not there's not a big difference between the two samples. That's your null hypothesis. And then you've got your alternate hypothesis, which is there is a significant difference between the two samples. Because the p-value is 0.188, that means it is higher than the alpha of 0.05. And since it's higher than 0.05, that means that you would have to accept the null hypothesis, saying there's not a significant difference between the two samples. So I don't know how they came up with that figure, because on X, your values are between 10 and 15, and Y, your values are between 5 and 16. But that's what it came up with on the p-value. So what we're going to do is we're going to interpret the result. So if the RHO is 1, you print perfect positive monotonic relationship. If RHO is -1, you print perfect negative monotonic relationship. If RHO is greater than 0.7, it's a strong monotonic relationship. If ABS RHO is greater than 0.5, you have a moderate monotonic relationship. If the absolute value of RHO is greater than 0.3, you have a weak monotonic relationship. Else, you have no significant monotonic relationship. And since the correlation, the RHO is 0.7, it's just on the cusp between moderate and strong, but since strong is greater than 0.7, 7. We have to say that there is a moderate monotonic relationship. So that's it for this video. The next video we'll be talking about a chi-square test of independence, and I hope that you decide to watch it.